Domain 3 is the biggest domain, 38% of the exam, and this video kicks off our three-part coverage of it. We're starting with the architecture and the development lifecycle. How do you design an AI system that's secure from the ground up? What does zero trust look like when the system you're protecting is a machine learning model? And what does secure development mean when the code is trained on data, not written line by line? These are the questions this video answers. Let's build something secure. Domain 3 is where the exam gets the most technical, but don't let that intimidate you. It tests both technical depth and managerial judgment. Sub-area 3A covers architecture and design. 3B covers AI lifecycle security. 3C is data management controls. 3D is privacy, ethics, and trust controls. 3E is security controls and monitoring. Across all of these, the exam asks which control or architecture is most appropriate for this scenario. Your job is to apply the right framework to the right situation. The exam is weighted roughly equally between security managers with a CISM background and those with a CISSP background, so both governance and technical answers will appear. When in doubt, lean toward the governance and risk perspective rather than the deep technical one. 4 principles anchor AI security architecture. Defense in depth means layering security controls across all components. Your AI system should not have a single point of failure or a single line of defense. Zero trust architecture means no implicit trust. Every API call, every access request, every service interaction must be verified before it's permitted. Privacy by design and security by design mean that these aren't features you add later, they're requirements you define at the beginning of the architecture process. And the principle of least privilege means that every component, every user, and every service has the minimum access necessary to do its job, nothing more. When the exam presents an architecture scenario and asks which principle applies, these 4 are your answer bank. Memorize them with examples, not just definitions. What does the exam actually test within AI security architecture? Infrastructure security. How do you secure the compute, storage, and GPU environments where AI models train and run? Identity and access management. Who can access which model, from where, and under what conditions? Cloud-native AI security. Understanding the shared responsibility model in cloud environments like AWS, Azure, and GCP, specifically as it applies to AI workloads. And architecture risk assessment, applying threat modeling before any AI system is designed or built. The exam will often give you a scenario involving a proposed AI deployment and ask what the security manager should do first. The answer is almost always conduct a threat model or architecture risk assessment. You assess before you build. Let me make zero trust concrete in an AI context. Every service, every API, every user accessing your AI environment needs to be authenticated and authorized every single time. There's no once you're in, you're trusted. Microsegmentation takes this further. Later, your model training environment is isolated from your inference environment. The pipeline that prepares training data is isolated from the pipeline that deploys the model. Even if an attacker compromises one segment, they can't move laterally to the others. And every access to models, data, and APIs is logged, creating a complete audit trail. In a project I was involved with, a vendor had read access to a client's production AI API that was never revoked after a pilot. Under zero trust, that access would never have persisted. It would have been time-limited and would have expired. Zero trust prevents that entire category of risk. Here's an important nuance the exam tests. The AI security manager's role is to advise on architecture, not to design it. This is a governance and oversight role. You're the person who maps AI components to existing enterprise frameworks like TOGAF, SABSA, or Zachman. You're the person who ensures governance checkpoints exist at every architecture review gate so that a new AI deployment can't go live without security sign-off. You're the person who identifies common risk patterns, shadow AI connecting to enterprise systems through ungoverned APIs, AI components coupling tightly with legacy systems that have no security controls, AI tools introduced by business units without IT involvement. The exam tests whether you understand the manager's advisory role versus the architect's execution role. Don't blur that line in your answers. The secure AI development lifecycle mirrors the traditional secure SDLC, but with AI-specific controls at each phase. Phase 1 is planning. Define security requirements alongside AI functional requirements. If security is not a requirement from day 1, it will be a problem on day 100. Phase 2 is data preparation and training. Validate data integrity, implement access controls, track provenance. Phase 3 is model development. Apply secure coding practices, conduct peer reviews, and avoid embedding secrets in code. Phase 4 is deployment. Harden the deployment environment, validate the model through the TEVV framework, restrict access to production. And each phase should have a security gate, a checkpoint that must be passed before moving to the next phase. The exam tests whether you know what security controls apply at each phase, not just that the phases exist. The TEVV framework is ISACA's preferred approach to AI model validation, testing, evaluation, verification, and validation. Testing is the broadest category. Functional testing, adversarial testing, bias testing, and robustness testing all fall here. Evaluation assesses model performance against defined metrics and acceptance criteria. Verification confirms that the model was built correctly. It does what the specifications said it would do. Validation confirms that the right model was built. It addresses the actual business problem in a safe and reliable way. The exam distinguishes between functional testing and security validation. Passing functional tests does not mean a model is ready for production. You need both. Red team exercises that specifically target the AI model, trying to fool it, poison it, extract it, are a key component of adversarial testing and should happen before every production deployment. When it's time to deploy, hardening the environment is essential. Disable unused services and ports. Remove development tools from production environments. Manage secrets properly. API keys, credentials, and tokens must never be stored in model code or configuration files. Use a dedicated secrets management solution. All inputs to the model must be validated and sanitized. All outputs from the model must be monitored, not just the inputs. Secure API design for AI means rate limiting to prevent model extraction attacks, strong authentication on every API endpoint, and output filtering to prevent sensitive data leakage. I've seen organizations spend enormous effort securing the model training environment and then deploy the inference API with no authentication because it's internal. Attackers don't distinguish between internal and external. They exploit the weakest point. Model lifecycle management doesn't end at deployment. Updates need to be managed carefully. A/B testing lets you run a new model version in parallel with the existing one before full cutover, so you can validate the new version's behavior before exposing it to all users. Version control for AI models needs security controls. Not everyone should be able to promote a model to production. When a model reaches end of life, decommissioning must be thorough. Delete the data, sanitize the model, revoke all access. And a post-decommission review confirms that no residual data or model exposure remains. The exam frequently tests decommissioning scenarios. The correct answer always pairs data sanitization with access revocation, both, not just one. MLOps integrates the AI model lifecycle into CI/CD pipelines, and security must be embedded at every stage. CI/CD pipeline security means scanning code, containers, and dependencies on every build, not just at release time. Model registry security means signing and verifying every model artifact before it's deployed, so you can be certain the model in production is exactly the model that was approved. Developer guardrails include an approved tools list and secure coding patterns specific to AI, because AI development has security pitfalls that aren't in your standard secure coding guidelines. Things like hard-coded data paths, unvalidated training data sources, and overly permissive API access are common AI-specific coding errors. MLOps security is where DevSecOps meets machine learning, and it's an area where the exam expects you to understand both the concept and the specific controls. Let me close with the exam tips for architecture and lifecycle. For architecture questions, zero trust and defense in depth are almost always strong answers. Apply them confidently. TEVV is ISACA's preferred AI validation framework. Know all four components and what each one confirms. For decommissioning questions, the correct answer always includes both data sanitization and access revocation, not just one. And pay attention to role language in questions. Advise on architecture means you're the manager providing oversight. Design architecture means you're the technical architect executing the design. The exam uses these terms deliberately, and confusing the roles will lead you to the wrong answer.